In today's world, mobile photography is everything. Over 85% of photos are taken on smartphones. Yet switching between lens types like macro, fisheye, or telephoto usually requires bulky attachments or multiple kits. This creates a barrier for content creators, influencers, and especially everyday users who want flexibility without the hassle. Our solution is a swiveling smartphone lens system that lets users easily rotate between different lenses, all in one compact device. It's cost effective, convenient, and designed for portability. The market potential is massive, valued at $4.5 billion in 2023 and growing at a rate of 7.2% annually. Our primary target market includes millennials and Gen Z users aged 18 to 40, especially those passionate about photography, social media, and travel. This product aligns perfectly with the booming creator economy and the rising demand for smart, user-friendly mobile accessories.
So looking at our initial concepts, it includes the smartphone lens attachment, the desk lamp, and the laptop stand. And we went with the lens attachment because it had a high impact in the market and a large target demographic. So our initial CAD shows our first concept, which drew inspiration from a windmill-like rotating mechanism. And the idea was to house multiple lenses on rotating arms, allowing users to spin through the options. But we abandoned this design because the rotating arms consume too much internal space and it increased the risk for misalignment. So as we took a deeper dive into the CAD, we initially developed a sliding mechanism that required precise XYZ adjustments to maintain optical alignment with really tight tolerances. This approach introduced manufacturing complexities like CNC machine precision rails and increased part count, while space constraints conflicted with the slim case profile goal. A subsequent ball swivel mechanism simplified motion to a single axis rotation, reducing alignment risk and improving user intuitiveness, which is what we chose over the lateral lens movement. However, machining tolerances caused wobble issues, and the lack of tactile feedback led to user overshooting and not the cameras aligning properly. The major breakthrough in our project came through when we decided to use a ball detent system using spring-loaded balls that snap in notches during rotation. This design achieved alignment precision through stainless steel components capable of thousands of cycles without wear. The audible click provided clear user feedback while simplifying manufacturing through stamped detent plates. To optimize performance, the system was limited to macro and fisheye lenses based on market research showing strong user preference for these styles. This focus allowed millimeter perfect alignment tailored specifically for the iPhone 12's camera, avoiding universal fit compromises. Addressing traditional clip-on frustrations, the ball detent snap-to-lock mechanism enabled swaps without threading or realignment. This eliminated the misalignment risk inherent to screw-based systems while maintaining the case's sleek profile. The design evolution prioritized user experience metrics, reducing swap time from 15 plus seconds with conventional systems to under 3 seconds, while ensuring optical stability through rigorous mechanical testing.
Okay, so our product is a clip-on phone lens mount. We called it PivotPix. So you have snap fit joints that will snap onto the back of a phone, and then it's designed for my phone, and then there are ball detents inside so that they'll click into place. And then so you can go from your normal camera, and then we have a macro lens and a fisheye lens, and then you can move it and then it'll go and snap into place. And then here's an example of it being used. So you have the normal camera. This one is the macro, which will just get really close up pictures. And then you can switch to the fisheye, and then it'll do like that.
So besides the metal ball detent, most of the product is made from PETG through 3D printing. We're pretty satisfied with this choice for the prototype because the plastic is decently durable, but it's also lightweight and flexible, which allows for the snap fit. And the 3D printing process is also pretty simple and cost effective. So while it's not the best, for a simple prototype that's just meant to demonstrate the idea, it gets the job done pretty well. For a more refined prototype, we would still want to stick with 3D printing because of its simplicity, but switching to a more durable material like nylon could be beneficial for its increased flexibility and impact resistance. Now, if we were to start manufacturing our product at a larger scale, switching from 3D printing to injection molding would be a smart choice, because injection molding tends to be better for mass-producing plastic parts in terms of both consistency and cost-effectiveness. CNC machining is also another option for precise manufacturing, especially for the metal parts like the ball detent or any metal pins.